Hello guys, today we are going to discuss the LeetCode problem under backtracking track. So as you know, we have already discussed the problem from 1 to 7. So today we are going to discuss n queens. So the problem is like we are given a n cross n chess in cross n board and we have to place the queens such that no queen attack each other. So how we can say that no two queens are attacking each other? So two queens are said to be attacking each other if two queens shares a same row, same column or same diagonal. Means like if let's say the queen that is placed at 8D, you can say 8D, this one. So the queen at cursor. So if you say like if another queen is placed in the same row, then it is said to be attacking. If any queen is placed in this in this row itself, D column itself, then it's said to be attacking. And if any queens placed like say at 7E or like you can say 7C, then it is said to be diagonally attacking. So and similar goes for upper diagonal and upper right diagonal. Okay, so no queens can be placed in these, you can say 1 2 3 4 5 6 7 and 8 and in similar way, like you can say like in 8 in these 8 directions actually. So there are no if there is no queen in these 8 directions corresponding to a queen that we are considering, then we can say that our placement is safe. So in this way, and under these conditions, for each queen we are supposed to place n queens on the board. So how we are going to solve this problem actually? So we are going to solve this problem using backtracking. So how we are going to apply backtracking here? So we can apply backtracking in this manner, like first we place a queen, okay, and then we check like if by placing this queen, and then we recursively try to place all other queens. So if we get a solution, then we know that this is the candidate solution. And if by placing this queen we are not able to place any other queens on the board, then we would backtrack from this position, the current location. Then we have to backtrack actually. So in this way we will solve this problem actually. I you might have been familiar with the backtracking, as I have already discussed like 1 to 8 videos on that. So let's start to code. Here in the question we have to return those configuration of the boards actually, and let us see in what companies this problem appears. So this problem appears in Amazon, Facebook, eBay, ByteDance, Rubrics, Uber and Google, Oracle, Microsoft, Adobe and Apple. So this problem is important, so we should do it. So the we need to return the configuration of the boards. So we'll need to make that variable here. Let's name it answer. New list, okay. And we also need to make a grid for placing the queens, and that is n cross n. And we'll initialize the grid with the dot. Dot means empty. So we have initialized this, and we'll start by placing queen from the 0th row. So let's say we are placing in the first, we start placing the queen in the 0th row and 0th column. Then we'll try to place queen with like 0th row and first column in similar way. If we are done with the first row, then we start proceeding with the second row and then third row and then fourth row in the similar manner. So we'll start from 0th row, and total number of queens that we have to place is like n. And one more thing, to detect if any other queen is placed in the same row or same column, we should need to take off a set so that we can identify easily without wasting time. Let's name it positions where the queens has been placed. And let's pass the grid here, and in the end we return answer. Private word solve int row int n, you can say like char grid. So we know that if we have placed all the queens, then our r equal to n. So if this is the case, then we know that we have already placed all the queens, so we need to add that grid to our answer. So what we will do, like we'll create a string buffer. We create a list first of strings. Let's name it result. And for each row we have to add this configuration. J plus plus grid I comma j equal to dot, then what we supposed to output dot only, then sb dot append dot else sb dot append q, and at the end we should attach this result, add this result into the list by converting it into the string. And we have added this into our res array, and after this outer for loop breaks, we need to add that to our final answer. And we'll simply return from here. And if that is not the case, then we'll try to place the queen in the row that is given to us. So in our case, we are supposed to place the queen in rth row. So we'll try to place the queen in rth row column by column. So we'll traverse in each column I equal to 0 and I plus plus. We'll check if we can place the queen here. So let's name it if valid or comma I. If we can place the queen here, then we'll place the queen. We make like grid r comma I equal to q, and recursively add this position into the set, into the position pos dot add r star n plus I, and recursively solve for other. We can say r plus 1 n and grid. and after that we will revert this change, because we have to try all the positions and we need to add all unique answers into our final answer. So r comma I is going to be dot pause dot remove r star n plus I. So in this way we can proceed for this problem. I think we have completed the code. Let's run it. So yeah, valid function is not yet, we haven't implemented this, so let's implement it. So private boolean valid, it is taking like int or int c. So we'll check if pause dot is empty, will simply return true because we know that there is nothing to compare. Otherwise we will check with each of the positions where we have already placed the queen actually. So let's say int x, so int row equal to x divide by pass, let's say we are passing n as well here, n as well. We get the row, we need to check the column x mod n. So we'll check like if r equal to row or c equal to column or math dot apps equal to r minus row equal to math dot apps c minus column. This is for diagonal, this is for row r equal to row, and this is for column, and this is for diagonal entries. Then we simply return false. Otherwise we'll return true. Let's run it now. Yeah, so it is successfully running. Let's make it for 4 5. Let's see. So yeah, it is running perfectly fine. Let's submit it. So hope you have liked this video and backtracking concept. For more videos like that, do subscribe my channel. Thank you for watching.